Hey there, kiddos. Today we are doing lesson 4 in module 4, and it's a big guy and it's very important. And if you just can't stand using tape diagrams, today is your day. You are going to learn how to use these and you're going to learn how to love them. Can we hear a huzzah? All right, well, just kidding. We are going to work with tape diagrams a lot, but if you don't love them, I really hope that you see the value in them by the time we're done. Okay, so the objective kind of piggybacks on the previous objective from lesson 3, understanding fractions or interpreting a fraction as division. And so we're gonna use the fractions with our expression and the standard algorithm in division to create a tape diagram. We're going to tie it all together so that you'll see how you can have an expression like this that's turned into a fraction, and it'll help you solve things. These pictures are so valuable when you are stuck on a word problem. So let's take a look. There are a few sample problems that are in the teacher's edition that kids don't have access to. Very important to get these notes down. For example, problem 1. 8 tons of gravel divided between 4 dump trucks. How much in one dump truck? Roughly, with a whole bunch more words, but that's the gist of it. So you have to really understand, what is the whole? What is the whole? It's 8 tons being divided. 8 goes on top. It's divided between 4 trucks. Inside the tape diagram, you would split it into 4 sections. Initially, you won't have the 2's inside because all you know is the 8 divided into 4 pieces. So as it starts out, you're going to take your 8 and you'll be dividing by 4. That's your fraction, or connecting to lesson 3. We will today be doing the standard algorithm. So 8 divided by 4, 2 tons per truck. This is 1 truck. You can put the 2's in if it helps you understand. What we have to do also, they want you to understand what a unit is. A unit is one of the pieces. If you can figure out the size of one, you can figure out the size of any. So they're saying if 4 units make 8, then in order to find 1 unit, it would be 8 divided by 4, which is what we're doing here and what we're doing here and what we're doing here. So it's all that redundancy again, doing it over and over. When you do the 8 divided by 4, you get your 2. 2 is your answer, 2 tons per truck. And so we're going to do this a few times just so you can start seeing how to build the whole. There is a check piece that's worked in that you can see in problem 2. This time we're changing the total tons of gravel to 5. So you change the total or the whole to 5, but we still have 4 trucks. So how much would be in one? So you take your tape diagram, you divide it into the 4 pieces, but put 5 on top. 5 divided by 4, 5 is the whole, 5 divided by 4 in the fraction, 5 divided by 4 in the standard algorithm. What you're getting now is a mixed number for your 1 truck load. The next step that you're going to do is to check, and because we technically do not know how to multiply mixed numbers times whole numbers, maybe you do, but in the book we haven't gotten there yet, we're going to do repeated addition. Add up the wholes, add up the numerators, simplify whatever fraction is here for the total. Compare the total to the whole, which is what would show that you were successful, and then you know you've done a good job. Look at the units that they also want you to understand. It's like, here are all the units. 4 units make 5. So how much is 1? That's where we have the 5 divided by 4, which we have over here 3 times, and then we get our 1 unit for 1 1/4. Okay, more work back here. Problem 3. A 3-meter ribbon cut into 4 equal pieces. What is the length of each piece? 3-meter ribbon, you should probably stick with the labels too, divided into 4 equal pieces, 1, 2, 3, 4. So it's important to know what the whole is and what the pieces are. Okay, again, the division, long division. Today we are not going to annex decimals and zeros. You're going to stop in the ones place and put your remainder in a fraction, and you'll be using the check with the repeated addition. Okay, you'll have potentially an answer that's less than 1 for your 1 piece, and so you'll just be doing repeated addition. 3, 6, 9, 12. 12 fourths makes your 3. 3 is the whole, And so you know you did it right because it matches. Problem 4, 14 gallons of water, 3 fish tanks. How much in 1? How much in 2? And so if you take your 14, divide the tape diagram into 3 pieces. 14 divided by 3, 14 divided by 3. Do the division. Take your whole number. Remember, you got to know the steps of division. 4 times 3 is 12. Do the subtraction and get 2. This is the end of your division. 2 is the leftover remainder that goes over 3. Here is your mixed number. Check it by taking your quotient each time and multiplying by the whole number on the outside. When we're not multiplying, we're using this number to tell us how many times to repeatedly add it. Okay, repeated addition is multiplication. That's why I'm tying that in there. So we have to do the addition here to get all the whole numbers. 4, 4, 4 makes 12. 2, 4, 6, there's your 6/3. Straighten that out into a 2. 12 plus 2 is 14. Lots of stuff in the notes today. It's huge. I know, I apologize that it's 6 minutes, holy moly. So let's get into the book, see how much we can cover. So you're going to draw a tape diagram to solve. You will express your answer as a fraction, okay, so that we can see what the answer would be. Then show the multiplication sentence here to check your answer, but then solve it by using repeated addition. Here's your standard algorithm that'll be in the middle section. Tape diagram, standard algorithm, put your units below, check with repeated addition. Whew, it's a lot. So let's make a little section for us so we can have some room here. So I have 2 divided by 3, okay? And right away, you can put your 2 divided by 3. You can put 2 over 3 on the little number line if you would prefer to do that, but it's nice and big here so you can see it. 2 divided by 3. So I have my tape diagram. 2 is my whole. First number is the whole. It's divided into 3 pieces. You can have any size whole and any size divisor. Don't get stuck with it has to be bigger here and smaller there. No, it doesn't. Okay, and for the standard algorithm, or you can put your label down here, the label in our unit form, so 3 units make 2. If you want to set it up with your division so you can see what the answer would be, which we kind of already have, but it's 2 divided by 3. Okay, so does 3 fit into 2? No. 0 times, but with 2 as a remainder. Stop here, don't annex anything, put your 2/3 as your kind of answer. Now this is what we're going to be doing with, using with our check. And so it's 3 times 2/3. We're connecting to this written method, 2/3 plus 2/3 plus 2/3. So we're writing it all out. You get your 6/3, which is equal to 2, which is the whole that we started with, okay? So that's what we want. Now we're going to go back over here because not only do we have our setting it up, but we have to find out what would be the size of each piece. So now you're going to look at the 1 unit being 2 divided by 3. 2 divided by 3. Put that into a fraction, and that's your answer that you're carrying here, but it's a little easier to see here. Okay, so those are all the things that you have to do. Let's move on and do another one. So if I have 7 is my whole divided by 5. 7 divided by 1, 2, 3, 4, 5. Let's pretend those are exactly the same size pieces. Okay, so our whole, or how many units do we have? And that's going to be your pieces. So 5 pieces, 5 units equals 7. Okay, so if you want to know what 1 unit is, hardly gave myself enough room. 7 divided by 5. That'll be this piece. Okay, now it's going to be 7 divided by 5, or 7 divided by 5? A little bit repetitious? Yes, it is. 7 divided by 5. Standard algorithm. 5 goes into 7 one time. Multiply. Subtract. Stop here. Put your fraction answer so that I have a full mixed number, 1 2/5 times 5. It doesn't matter which number you put first. Does not matter. We're just going to be repeating the mixed number 5 times. 1 2/5. This is 2 times, 3 times, 4 times, 5 times. Hard not to write 5 when I'm saying 5. Okay, add them all up. 1, 2, 3, 4, 5. Add these up. 2, 4, 6, 8, 10. Put it over 5. 5 is your denominator. You're going to figure this out or straighten it out. 10 divided by 5 is 2, and then you get your 7. I'm way down into the territory of the next problem. Oops. Crossed that right out, didn't I? Okay, so 7 is the whole, and you can move on to the next one because everything matches. We did it all correctly. Okay. Next one, 14 divided by 5. Nice tape diagram. 14 is the whole, divided into 5 pieces. Again, if we're going to create our unit form here, it's going to be the number of pieces showing the total. I would really like to know what 1 unit is. And so it's going to be 14 divided by 5. 1 unit will have this fraction. This is how you set it up. 14 divided by 5. 14 divided by 5. You can always just go straight from here to here, do all this, and then come back and do that if you like. 5 goes into 14 2 times using 10 with 4 left over. 4/5 is your fraction to go with the 2. When you want to check that, again, I have to write it 5 times. So 2 4/5. 1 time, 2 times, 3 times, 4 times, 5 times. 2, 4, 6, 8, 10. 4, 8, 12, 16, 20 fifths. 20 divided by 5 is 4. You get your 14, which is what you had for your whole. So it's just kind of repeating. It's like you're looping yourself around on all these problems. Okay, let's do the back. Don't be afraid. I know it looks like a lot, and it is a bit, but just keep thinking about how these numbers relate to each other. It's very important. They've got 4 different categories. Division expression means just writing what the whole is divided by the parts. The fraction, as opposed to yesterday, it won't be, say, a proper or improper. It could be either. And then between which 2 whole numbers is your answer? Most people would say, what numbers is it between? But it's not proper to end a sentence with a preposition, so they put it first. So this is grammatically correct. Then the standard algorithm, you're going to prove it. And so it's easy to kind of jump around. I do love the fractions and the standard algorithm. It's very closely connected with the division expression to make it easier for you. So let's jump in. This is done. 6 divided by 7, 6 divided by 7. 6 divided by 7. Can 7 fit into 6? No, it can't. If I was to multiply, I would get 0 with 6 remaining. 6 can be my remainder out of 7, leaving me with 6/7. So where does this fraction live? Between which 2 whole numbers is your answer? It's between 0 and 1, because here's the 0 whole number, and 1 would be 7/7. So that's why this is 6/7 is between 0 and 1. Okay? Now they've taken away a little bit of scaffolding. They took away a little of our help, but that's okay. We can easily solve this. 55 divided by 10. Remember, this is a division sign, and lesson 3 is fractions as division. 55 divided by 10. 55 on the inside divided by 10 on the outside. This one is an improper fraction, so I have a large amount in here. 10 can fit into 55 5 times for 50 with 5 left over. If 5/10 is my remainder, then where does this whole answer live? Well, 5 is the low part, and 6 would be the next whole. 5/10 is equal to half, so it's really exactly in between 5 and 6 at 5 1/2. All right, let's do the last one on this page. Look how quickly you're getting through this. 32 divided by 40, 32 divided by 40, 32 divided by 40. Now this one is a proper fraction. That means that 32 is less than 40, so my number is less than 1. So this is going to be real easy, but we'll solve this first. Can 40 fit into 32? No. When you multiply, you get 0. What do you do when you subtract? You get 32. So that leaves me with 32/40 as my answer. So where is your answer? It's between 0 and 1. It's the same thing as this. Your fraction, no matter what it looks like, 32/40 or 6/7, if you don't have all the pieces, it's less than 1. Okay? Let's see if we can finish this up in one video. Greg spent $4. That's all he had total on 5 packs of sports cards. How much did Greg spend on each pack? So we got to know money. So we're going to take our $4 and we're going to divide it by the 5 packs of cards he bought. So again, it's taking the tape diagram picture, making an expression out of it, which turns into a fraction, which you can then divide. Now, this one says, how much did he spend? So we don't necessarily need to say he spent 4/5 of his dollar. We're trying to figure out the cost. So what is the cost that he spent on each pack? So take your 1, what would be like your dollar, okay? Because he's got 4 of them. And we're going to divide it by 5. Okay, so that you can see, multiply here, get 0, and we have 20 cents. That would be 1 part of the dollar. But he has 4. So it's going to be 20 cents times 4 for 80 cents. And you could do repeated addition there if you prefer. But 4/5 would be 80 cents per pack. Okay? 4/5 of a dollar per pack, which works out to be 80 cents. Okay, moving right along. If Greg spent half as much money, $2, and bought twice as many packs of cards, change your total, change your tape diagram. Instead of having 5, I'm going to split it and put 5 on one side. 1, 2, 3, 4, 5, and 5 on the other. 1, 2, 3, 4, 5, for a total of 10. How much did he spend on each pack? Here's where you can take your 2 and divide it by 10. 2 divided by 10. Now that we've done if you look at the value of a dollar and breaking it up into pieces, if you had a dollar and you broke it into 10 pieces, what do you have? For 1 piece, you have a dime. And so you're taking 2 dimes, which is worth 20 cents. So 2/10 of a dollar is going to be not $20, but that's how you write 20 cents or 20 cents. That is okay too. This would be a time when you could say if 10 units make 2, 1 unit is 2 divided by 10, or 2 divided by 10. And that's where we're going with that. Okay. How much do you spend on each pack? Explain your thinking. You can just kind of say, you know, I'm going to break a dollar. Break 1 into 10 parts and multiply by 2. There you go. All right, so let's jump into 4, and then we've got 4ABC, and you're done. So, oh, and also click subscribe, come back again. I will try to help you with math. 5 pounds of bird seed is used to fill 4 feeders. This one's fun. What fraction of the seed will be needed to fill each feeder? So what they're saying is, if you have 4 feeders, what fraction is used to fill one? What fraction of the seed? Don't get confused by the 5 pounds here. They don't care at this point. It's 1/4 of the seed is needed. There's almost no question there. Like, you're looking at it and you're going, well, I know that's 1/4, but it's just so, I don't know. I don't like it. I feel like it's a trick question, but anyway, there it is. So 1/4 of the seed is needed to fill each feeder. It's like, duh, of course it is. You have it in 4 pieces. So for B, you finally get to do the calculating. So how many pounds of birdseed are used to fill each feeder? Now you can take your numbers that you have, your 5 pounds, divided by the 4 parts, and 5 divided by 4, and then you've got your 5 divided by 4, or vice versa, 5 divided by 4, and then you can go through your steps of the long division, subtract, and get your 1 1/4 pounds per feeder. So how many pounds of birdseed are used to fill each feeder? 1 1/4 pounds. If you wanted to check it, you could do your 1 1/4 pounds 4 times, and you would see that you end up with your 5 pounds. 1, 2, 3, 4, and then 1, 2, 3, 4. 4/4 makes 5. Okay? So that's your check. Finally, we have a bit of a challenge here. Don't forget about converting. This is ounces. So how many ounces of birdseed are used to fill 3 bird feeders? Not just 1, but let's just focus on 1 for the time being. If 1 1/4 pounds is what 1 is, then the ounces would be 16 ounces for 1 pound. Okay, that's one of those conversion things that you'll probably have to know. If you just memorize it now, it's better for you. So if this is already 16 right here, then I just need to know what 1/4 pound in ounces. And so if you take 16 and you divide it into 4 pieces, because that's what you need to do, you get 4 ounces for that extra fraction, which gives you 20 ounces for 1 feeder. So you're going to take your times 3 to get 60 ounces for 3 feeders. And I hope this has been instructive. I hope it has been helpful for you. And I hope you come back again, and we will see you on the next video. Bye for now.